This question is asked in GATE 2022 of Electrical. This is from Control System subjects and related to the Bode plot topic. The question is, the Bode magnitude plot of a first order stable system is constant with frequency. The asymptotic value of high frequency phase for the system is minus 180 degree. This system has, if you see the options, one left half plane pole and one right half plane zero at same frequency. Similarly, if you see, they are basically asking us to find how many poles and zeros will be there to satisfy this criteria and where they will be located, how they will be located, right? So let us see. Here, one important keyword that you should notice is they are saying that this is what a first order stable system. What is the meaning of it? That means if I say the transfer function for which the Bode plot is given, okay, so this will be in the format of k multiplied by some pole, let's say p. So here, first order means what? First order means there is only one pole. That is the meaning of order, right? So we have only one pole. And again, the word stable system is used. That means that pole must be lying on the left half of S plane. So qualitatively, if I ask you how does the pole, where the pole will be located, so I can say the pole will be located somewhere here. Because it's a stable system. Stable system means pole should lie on the left half S plane. So the first point, it is given that first order. First order means only one pole is there. And whether it will be in left half or right half, so because the stable system is given, it should be definitely on the left half of S plane. So what is this pole locations? So let's say for understanding purpose, I'm taking it is minus 1. If I take it minus 1, then this is like k into s plus 1. K is a multiplying factors because we don't know what is this magnitude. So let's say it is k. It can be 1 or something else as well, no problem. Okay, so the discussion regarding pole is over. Now it is basically regarding the zero. So whenever the magnitude is constant for all frequency, this resembles a all pass filter behavior. And in a all pass filter behavior, the poles and zeros, they are symmetrical with respect to j omega axis. In other words, if I'm saying I have a all pass filter having the pole at minus 1, it means there is definitely 0 at s equals to plus 1. So that this pole zero plot is symmetrical with respect to this j omega axis. So this location is 1 minus s. So if you equate the, you'll find the 0 is at plus 1. So, so this particular transfer function will satisfy this criteria. So h of j omega, to show you in more detail, is k into 1 minus j omega divided by 1 plus j omega. So if I ask you to write this magnitude and phase, magnitude is k and this is 1 plus omega square root divided by 1 plus omega square root, and the phase is minus of tan inverse of omega from the numerator, and for denominator again it is minus of tan inverse of omega. Now if you see this and this will be cancelled, so this is k at a phase of minus of 2 tan inverse of omega. Now if you check it out, so what is at low frequency and high frequency? So at low frequency, h of j0, its magnitude is k, and the phase angle, if you substitute omega equal to 0, this is 0 degree. And if you substitute, it is, j of, like h, omega equal to infinite, this is again k, and at infinite, tan inverse of infinite is 90, 90 into minus 2 is minus of 180. That's what we need. So at high frequency, the phase is minus 180 degree. At low frequency, the phase is 0. And you can see this k is independent of frequency. That means for all frequency, it will be some constant k. Okay, so what is the conclusion? So let's check the options. Option D, 2 right half poles and 1 left half 0. 2 right half poles. We have only one pole. This is wrong. In the same logic, again, 2 poles. This is also wrong, right? So now going to the option B, it is saying that 1 left half of pole. Okay, that is fine. And 1 left half 0 at same frequency. This is not fine. The 0 is lying on the right half of S plane. So option B also wrong. So definitely option A has to be correct. 1 left half of pole, okay. 1 right half 0. Yes, this is correct. So definitely option A is correct. Some students may think, sir, okay, you have taken this, that is well and good. But can I take, in this case, for this, can I take, this is k into s minus 1 by s plus 1. You may say this is all pass filter, but the phase criteria for this will not satisfy because at low frequency you are expecting 0. If you find the phase of this, what do you get? Of course, there is no change in the magnitude. but in the phase, if you see, so because of this particular term, it is j omega minus 1. So this will come in the second quadrant. Second quadrant means you will get 180 degree, then minus of 2 tan inverse of omega. You will get like this. So here at low frequency, the phase is minus 180. So this is not the transfer functions what we expect. This should be transfer functions. Anyway, this much of analysis is not required. So by observing the first phrase, that is first order stable system, the option C and D you can eliminate because it is saying it is having two poles. And once you know it's a all pass filter, definitely the zero should be lying on the right half of plane, not in the left half of plane. So based on that you can eliminate B. So A is the only right options. So directly you can eliminate the options and you can say either answer. It will take hardly 20-30 seconds to answer this, but in case for understanding purpose I was explaining you these all things. Anyway, the answer is option A. This question is asked in GATE 2022 of electrical. This is from control system subjects and related to RH criteria concept. The question is, the open loop transfer function of a unity gain negative feedback system is given by GS. The range of K for which system is stable is. So it's a unity gain negative feedback system, and in unity gain negative feedback system, the characteristic equation is given by 1 plus GS equals to 0. So that means 1 plus the GS value is K divided by S square plus 4S minus 5 equals to 0. So what is the characteristic equation? This is S square plus 4S plus K minus 5. This equals to 0. So this is a second order equations, and in a second order equations, the roots will lie on the roots will be negative, or the poles will lie on the left half of S plane, provided all the coefficients are of same sign. That is, all coefficients are either of positive sign or all are of negative sign. But anyway, in this case, this 1 is positive, 4 is positive. So we expect this K minus 5, it should also be positive. That means K should be greater than 5. If K is greater than 5, then the system will represent a stable system. Okay, very simple, because it's a second order equation, quantity equations. Its root will be negative, or in other words, its poles will be lying on the left half of S plane for stability. Because if you are expecting stable, we expect the poles should lie on the left half S plane. That means all coefficients of this equation should be positive sign, or all should be negative, or basically all should have same sign. So because already 1 is positive, 4 is positive, so the K minus 5 value should also be positive. So K minus 5 is positive, indirectly you expect K should be greater than 5. So if you see, it is given by option C. So C is the right answer for this question. This question is asked in GATE 22 of electrical. This is from control system subjects and from time response analysis topic. The question is, the damping ratio and undamped natural frequency of a closed loop system as shown in the figure are denoted as zeta and omega n. The value of zeta and omega n are. So we are given with this particular block diagram. So with respect to this, we have to find the value of zeta and omega n. So what is the approach to solve this problem? We'll be finding the closed loop transfer functions of the given block diagram, and then we'll be comparing that one with the second order standard transfer functions. So by comparing the denominators or the characteristic equations, we can easily get the value of zeta and omega n. So the first task is, let us try to get the transfer function. So if I ask you what is the open loop transfer functions, that is G of S is basically G of S, I mean this particular segment I am saying, okay? This is what I mean by G of S. So this one is G of S. Okay, so if you see, this will be, so 10 by S divided by 1 plus 10 by S. This is whole multiplied by 10 by S, isn't it? If you simplify, how much if you multiply SS, that is 10 divided by S plus 10. This is multiplied with 10 by S. So this happens to be 100 divided by S square plus 10S. Right, because this segment is again, it's a unity negative feedback closed loop system. It is again G by 1 plus G. So 10 by S divided by 1 plus 10 by S. This is in cascade with this 10 by S. So that's why I'm multiplying this 10 by S. By simplifying this, by multiplying SS, this factor is 10 by S plus 10, and this is 10 by S. 10 to 10 is 100, and denominator is S square plus 10S. Now, what is the closed loop transfer functions? If I ask you, then this is G of S divided by 1 plus G of S. So if you simplify this, it is 100 divided by S square plus 10S. divided by 1 plus 100 divided by s square plus 10s. If you multiply s square plus 10s in both numerator and denominator, this happens to be 100 divided by s square plus 10s plus 100. Okay, now if you compare this one with your standard transfer functions like k into omega n square divided by s square plus 2 zeta omega ns plus omega n square. If you compare with this one, I mean, which one will be comparing? This transfer function what you obtained from the block diagram with the standard second order transfer functions. So what is the comparisons if you make it? So you can see omega n square is 100, right? So omega n square is 100. So this implies your omega n is equals to 10. So we need to find zeta and omega n. Omega is n equal to 10 we got. Then by comparing the middle terms, okay, I mean 2 zeta omega ns equals to 10s. So I can say 2 zeta omega n is equals to 10. So zeta is equals to 10 by 2 omega n. Omega n already got it is 10. So 10 by 20 is 1 by 2 is 0.5. So zeta value is 0.5. So zeta is 0.5 and omega n is 10. If you see zeta is 0.5, omega n is 10. This is given in option A, and A is to be the right answer. This is one of the simplest questions in this paper. So like a very simple block diagram is given where no much skill is needed to obtain the closed loop transfer functions. So once you are obtaining the closed loop transfer functions, by comparing that one with the second order standard transfer functions, you are getting the value of zeta and omega n. So omega n is 10 and zeta is 0.5. So answer is option A for this. This question is asked in gate 22 of electrical. You may say this question is from control system and from the frequency response analysis topic. The question is, an LTI system is shown in the figure. Okay, this is the LTI system where g of s is given the transfer functions. The steady state output of the system to the input r of t. So this is what is the input r of t, and the output y of t expression is given. The frame of yt is given. The value of a and b will be. So what is a and b? A is the magnitudes, of the sinusoids at the outputs. So this is a very standard and repeated model questions. So whenever to a LTI system, if the inputs are sinusoids, what is the process to find the outputs? We'll be evaluating the transfer functions on the corresponding input frequency, like frequency are 0 for the DC and frequency is 10 for this AC. So we'll be finding the magnitude of these transfer functions at two frequency, that is omega equal to 0 and omega equals to 10. So accordingly, we may proceed then by multiplying the magnitude with the input sinusoids and by adding the corresponding phase. But anyway, theta value is not asked, so we are not interested to find the phase. We will concentrate only on the magnitude segments. Okay. So first thing is, so your g of s is given as 100 divided by s square plus 0.1 s plus 100. Okay. So because we need the frequency information, so I am replacing s with j omega. So g of j omega is equals to 100. So j omega whole square is minus omega square plus 0.1 j omega plus 100. If you simplify this, this is 100 whole divided by 100 minus omega square plus j 0.1 omega. Now if you find the magnitudes, okay, so this is 100 whole divided by square root of 100 minus omega square plus 0.1 omega whole square. So because in the inputs we have a DC, right, this A is the DC, so we'll be substituting here omega equal to 0. So if you substitute here omega equal to 0 or x equal to 0 also directly you can substitute, you can see. So this term will be definitely 0. Okay, and this term will be how much? 100 square, and 100 square again you have a square root, so it will be 100 and numerator also 100. So this will be definitely equals to 1. Okay, so at omega equal to 0, so this term is 0 and this term will give you 100 square, again you have a square root, so this will be equivalent to 100. So 100 by 100 is 1. So g of j0 is 1. So what is g of j10? Why I am finding g of j10? Because in the inputs the frequency is 10. Sin 10t, right? So I'll be substituting now, omega equals to 10. So if I substitute omega equals to 10, what do we get? So this term will be 0 because 10 square 100 minus 1 is 0. And here this term will be 0.1 into 10 is 1. 1 square is 1. So 1 plus 0. So this is basically 100. Isn't it? So G of J10 is basically 100. Okay. So while finding the YT, okay, what we'll be doing? So the input is 1 here, right? 1 into G of J0 magnitude. So this is also 1. 1 into 1 plus. In the next sinusoids, so the input sinusoid magnitude was 0.1 into the corresponding magnitude of the transfer functions at frequency 10, which we got it is 100. So 0.1 into 100, and then you have this sine of 10t, okay, then plus, okay, what is this phase? Because phase is not necessary. If you need the phase, so this will be phase of G10, okay. So if you simplify this, so this happens to be 1 plus 0.1 into 100 is how much? 10, right? Sine of 10t plus G of 10. So this is what is YT we are getting, and if you compare with the expression which is given here, so it is A plus B sine of 10t plus theta. Now if you make comparison here, A equals to B and B equals to 10. So A equals to 1 and B is equals to 10. This is what we are getting by comparisons. And if you check the options, A equals to 1, B equals to 10 is given in option A. So A should be the right answer for these questions. Okay. So this is a very simple and straightforward repeated model questions. So we can solve this way. This question is asked in gate 22 of electrical. This is from control system subjects and from the Nyquist plot topic. The question is, the open loop transfer function of a unity gain negative feedback system is given as g of s equals to 1 by s into s plus 1. The Nyquist contour in the S-plane encloses the entire right half plane and a small neighborhood around the origin in the left half plane as shown in the figure below. The number of encirclements of the point -1 plus j0 by the Nyquist plot of g of s corresponds to Nyquist contour denoted by n, then n equals 2. So how do you solve this problem? Okay, so here one important deviations from the regular model question is, so generally, so okay, in this particular transfer functions, we have two poles, right? One is at -1 and one is at origin. So generally, if we have a pole at origin, usually in most of the cases, we take the Nyquist contour this way. This is how we used to take. But in this case, to make the questions bit tricky, so intentionally they have selected the contour in such a way that this is enclosing the pole. Okay, that is what the deviation. If you see, Nyquist contour in the S-plane encloses the entire right half plane and a small neighborhood around the origin in the left half plane. That is what they are saying. I mean, this is being enclosed. That is what is being given here. Okay, so first thing is, this system is a stable system. Now you ask, how do I know it is a stable system? Because it's a unity gain negative feedback system and the open loop transfer function is given, right? So what is the characteristic equations? Characteristic equation is nothing but the denominator of the closed loop transfer functions. So our characteristic equation will be nothing but 1 plus gs equal to 0 in case it is a unity negative feedback system. So 1 plus 1 by s square plus s equals to 0. So s square plus s plus 1 equal to 0. Now it's a second order equations and all the coefficients are positive. That means what? If I find the roots of this, they will be definitely lying in the left half plane, right? So that means if the poles, that will be, it's a closed loop poles. If the closed loop poles are lying on the left half of S plane, that means the system is definitely a stable system. So indirectly, the information is given that this system is a stable system, right? The closed loop system is a stable system. Now the point is, so we know in the Nyquist stability we have studied that we have a generalized equations n equals to p minus z. This is in general true, and n is nothing but the number of encirclement about the point -1 plus j0. And what is this z? What is this z? Z indicates the number of closed loop poles on the right half of S plane. So in this case, because we already know that the closed loop poles on the right half S plane is 0, because all poles should lie on the left half S plane. So the number of closed loop poles in the right half of plane is 0. That means Z equal to 0. So naturally, the equation what you need for our particular question is n equals to p. So what is this p then? So p, what is the definition of p? So in the theory, you might have learned this p is nothing but the poles of the open loop transfer functions of the Nyquist contour. How many poles that it encloses the Nyquist contour? That is what is the definition of P. Generally, most of the books, okay, what you have learned some local author books, then you might have seen this statement. P is the poles of open loop transfer function in the right half S-plane. Why they say right half S-plane? Because they select that right half of S-plane in such a way that it doesn't include any poles. So for example, if I have taken this contour this way, okay, one second, if I have taken the contour this way, okay, I mean without including that origin, then in this case, if you say that one, the P is nothing but poles of G of H in right half S plane, okay, that is that might have true because you have not included that one, but in this case it is included. So by default, if somebody asks you to define what is P, this P indicates number of poles of open loop transfer function in Nyquist contour. Okay, how many poles of the open loop transfer functions are included in the Nyquist contour? Okay, that is one. So that is what the definition of P. Generally, instead of saying Nyquist contour, we say right half of plane. Generally, we used to take that one, and by default, we take that contour in such a way that it doesn't include any of these things. But in this case, the question is framed by targeting this particular points. So here, definitely your P equals to 1. So this is the equation we need, that is N equals to P and P equals to 1. So N equals to basically 1. So answer will be 1. So generally, most of the students who are weak in concept, what you might have done is, okay, so if I check with respect to -1, so it is not including any of these things, right? So the encirclement about this point is coming 0. So 0 will be the answer. You might thought that way. But the game is in this particular contour which is being selected here. It's a very nice question actually. So you should know this fact that P indicates number of poles of open loop transfer function in the Nyquist contour. Okay, so Nyquist contour is including one pole, so that one will come into pictures. So P equals to 1, that means N equals to 1. So it's a good logical question. If you know the concept, it will take hardly 30 seconds to analyze. If you doesn't know the concept properly, then you will be ending up with putting the answer as 0. So which is of course wrong. So 1 is the right answer for this question.